Hey LeetCode fam, welcome back. And today let's solve validate binary search tree. So yes, go through the problem statement once. So we'll be given the root of a binary tree, and we have to just determine if it satisfies the conditions of binary search tree. So yeah, the prerequisite to do this problem is to know what a binary search tree is, and I'll give an overview of what it is. Yeah, so we will be given a tree, and the tree is called a binary search tree only if the root value is greater than all the left subchild and smaller than all the right subchild. So if you consider this tree, then you can see that 2 is greater than 1, which is the left subchild, and it is smaller than 3, which is right subchild. So it is a binary search tree. But when you consider this example, you see that 5 is smaller than 1. So 1 is smaller than 5, so that's true. But 4 is smaller than 5, and that should not be the case because the root should always be greater than the right subchildren. So, and you might be thinking, okay, this seems like a really difficult question, how to solve it and all. And yeah, it is difficult if and only if you don't know what what gimmicks are present to solve these kind of problems. And if you know what in-order traversal is, then this question becomes like really easy to solve. So I'll tell you one good piece of information. Whenever you are given a binary search tree, the in-order traversal of that binary search tree will always give you then values present in the tree in the form of a sorted order. So yeah, if you don't know what in-order traversal is, or all the kinds of tree traversals like pre-order, post-order, in-order, level order and all, I highly advise you to go and check those out and learn it. So yeah, so what in-order traversal means is that first we check the left child, and then we check the root, and then we check the right subchild. So that is what in-order traversal means. So yeah, first we'll check 1, and then we will check 2, and then we'll check 3, left root right, left root right, 1 5 4 3 6, like that we have to go. And that is what in-order traversal means. And yeah, again I'll reiterate it. Whenever you have a binary search tree, the in-order traversal of it will always give you a sorted array. So the now you can easily come up with an algorithm. Just do an in-order search, in-order traversal of the tree, and if the given tree, and if the given array which you get on in-order traversal, if it is sorted, then you obviously have your answer. So yes, now let's solve it. In order, it will take the root, and what you have to do, you'll get an array. And what will the array have? It will have the in-order traversal of the tree, in-order traversal of the tree or root, and then yeah, and yeah, this should obviously work, and you have to use, you should not use assignment but the equation operator. And yeah, you can't do error dot sort over here because it will sort the array in place itself, and that's obviously not what you want. You want to check if the array which you have is sorted or not. So what you have to do is that you have to do sorted error, and what sorted does is that it creates a new list and then takes the values in the original list and sorts it and puts it in the new list. Yeah, so now how to do in-order traversal? There are many ways to do in-order traversal. You can do it recursively or iteratively, and over here I will go with iterative approach. So what you will do is you will take a stack, and then you will first put the root node at the stack, and till you have the left subchild of the node, you will go left and then add those values to the stack, and then you will pop the top of the stack, and then you will have the leftmost child. Then you will add the value of that child to our array, and then you will go to the right subtree. Yeah, that's it. It's a very simple algorithm. So stack, and while stack or root exists, because you have to do this process till all the roots are depleted and the stack is also empty. So while stack or root, so what you have to do, while yeah, root exists, you have to go to the left child, but you should not just go, you have to add that value to the stack also. And then is left, not left. Yeah, oh my god, I can't spell today. Left, yes. And then you'll pop the root node, and this will be the leftmost child. Then you'll take an answer array, and then you'll add the value of the root to the answer. So, and you'll take the root dot, well, yeah, to know if it is val or data, you have to just check the given definition of tree node, and over here the definition of tree node is self.val. So you'll get to know what it is. So root.val, you will append it to the answer, and after you append it, you have to go to the right subchild. So yes, and now you will have your array, which consists of in-order traversal of the given tree. So you can just return the array, which is answer over here, and yeah, this should technically work. Let's check it out. And yes, let's run it once, and you see it is passing the test case. So let's just submit it. Okay, and you see that there is a test case 222 which is failing. And why is that? There are multitude of definitions for binary search tree, and what these people have defined is that the left child must always be greater than the right child, and they are told that it should not be equal to. So how will you do that? Yeah, the best way to do that is to check for duplicate values, and if there are duplicate values, then obviously you can never have a binary search tree, valid binary search tree. So if arr dot, if yeah, let's just convert our array into a set, and let us call it in nar, yes, a new array. And if array becomes equal to new array, and it's not that we are comparing the array itself, but we'll compare the length. Yes, and you see now, then you will obviously return false, because duplicates are present, and according to the definition which LeetCode is using, duplicates should not be present. And yes, now yeah, it should be, if it is not equal, then you have to return false, mainly because if the length is not equal to the original length, that means duplicates are present. And yes, it's passing, and it's pretty efficient. Oh wait, now what you can do is, yeah, this also works, but why just keep it like this? Why do you use inbuilt sorting functions? And also let's just write a merge sort function and sort the array ourselves. So yes, I'll make another dedicated video on explaining how merge sort works, but over here I'll just give the bare overview. So you'll take an array. Yeah, this is like this is bonus script for you, and if you want to know how to write the merge sort code, then yeah, just keep on seeing it. So what is the idea of merge sort? The main idea is to break the array to smaller pieces till we have only one element, and then combine each element, and then compare each element, and then place them in appropriate order, like if you want ascending or descending order, yeah, depending on that you can do the comparison. So what you have to do, first you have to break, but you can't use break because break is a restricted keyword, like it is already used for something else in Python. So let's call break array and def break array. After breaking, what you have to do, you have to combine the array. So combine or merge the array. So let's do the breaking part recursively. So it will have array, and if the length of the array becomes equal to 1, that means if it becomes less than or equal to 1, that means we can't break the array further. So we'll return the array, or else let's calculate the midpoint, and let's calculate the left half, and left half will contain all the elements from 0 to the mid position, and right half will contain the elements from mid to the end of the array. And then now you have to recursively break both the arrays, and after breaking both the arrays, you have to do the comparison, and comparison and merging will be done in merge array part. So let's break the arrays recursively, and then you'll break the right half also. Yes, now since you have broken the array, now we can merge the array. What this will do is it will keep on breaking the array till we have the length of array to be equal to 1, and after you get the length of array to be equal to 1, it will directly return the array. So at the end of this, the array will become pi, and then a separate array of 1 4, ignore the narrow list, and then you will have 3 6 so on. So after breaking the array, you have to merge it. So you have to merge the array, and then after merging you can return the merged array. And yeah, what you have to do, you have to return the broken part of that, and the breaking part will take care of the merging part also, so no need to worry about that. So yes, now merger will take the left part and the right part. And I hope you understood how merge sort works, and don't worry, I'll make another dedicated video explaining how merge sort works. So yeah, what you'll do is you'll have two pointers, left comma, let's call it I comma j, and then you'll have answer array, and while I is less than length of left part, so what you will do, if left part at position I, if it becomes greater than right part at position j, that means right part at position j has a smaller value, so we'll add the left part to the left part at position I to the array. So after adding the left part at that index I, what you have to do, you have to increment the index, or else what you will do, you'll do the same thing, but it should become right part at position j, and after adding the jth index you will increment j by 1. Yeah, by now what will happen is, if the length of the array is equal, then you will have the sorted array, but if the length of the array is not equal, for example left part the length was 3 and the right part the length was 2, then obviously there will be elements left from the right part and you have to add that value also. So what you can do is, you can use the extend keyword again, rather than going while j is less than length of right part answer dot append j and then j plus plus, you can directly use the extend keyword. So yeah, that is how you have to know what you have to know all these things and keep them in your mind, and whenever you want it you should be able to use them. So what you will do, left part you can't directly extend the left part from, but you can only extend from ith position and from j to the end, and after that, yeah, now this should technically give us the sorted array. So let me just return true, and let us take the new array, or let's take the array and sort it. And yes, let's just check it out once. Yeah, it is not R, it is J. Yeah, what you're doing is you're adding the greater value over here, so it is reversing it's giving it in descending order. But if when you check for left part and right part, you have to add the smaller value to get the ascending order. And since over here what I'm doing is I'm checking, yeah, I'm telling right part is greater than left part, so add the left part or else add the right part. And now you see that let me print array over here. Okay, it's already sorting over here. Let me print it somewhere else. See, and as you can see, both the first array was not sorted, and as you can see over here, initially the array is not sorted, but after running the merge sort algorithm, the array got sorted. So yes, this is like a bonus clip for you. Rather than using inbuilt functions like sort and all, you can directly write a merge sort function, which will obviously show that you have knowledge to any recruiter who has asked you such questions and all. So yes, whenever you have the opportunity, don't use inbuilt functions, but try to write your own sorting functions and all. And don't let's call it a new array and then return yeah, it's called new array, not new array. And just remove all the print statements while submitting. And yes, obviously you saw I not only solved validated binary search tree, but I also showed you how to implement merge sort algorithm also here. So yeah, you can consider that part to be bonus, and you can honestly skip that part, or yes, depending upon what you want to learn, you can skip that part or just look at merge sort over here. But don't worry, I'll release a dedicated video discussing about merge sort. So yes, thank you.